Okay. Today we're going to talk about data binding in Android, which is one of my favorite topics because I think that data binding is a super magical, fun way to write a lot less code and make your project a lot prettier and do a lot of things auto-magically behind the scenes. And it just feels really clean in my personal opinion. So data binding introduced in 2015, which is 5 years ago, which begs the question, why are we still talking about it? For me, I think that most content started coming out in more like 2018 when they reintroduced it at a Google I/O to its full potential. And I also think Kotlin helped it along the way. But I also think it can be really confusing and so really useful to keep coming back to it and explain, because the first time you see it in a project or try to work with it, because it does seem so magical and so much is hidden, it can be really hard to understand. But with data binding, we can update our views without writing any code in the fragments. We don't have to use find view by ID. We can get rid of a lot of code, more concise, more organized. We can add logic to our layout files. So it's really powerful and really magical in my opinion. Obviously, like all code is not actually magical, but there's a lot of generated code. And anytime code is generated behind the scenes, it can definitely feel magical to you as a developer. So Vivian, I know you weren't here last time, but we're using the same app as I did last time for dependency injection with Coin and Hilt. So it's a really, really simple app. It fetches my commits from a repository and displays them in a recycler view. So you have a couple of edit texts, you have a button, you have a progress bar in the background, and then you have a recycler view. And that about makes it up. So just a couple of states and everything is controlled with data binding. We will see that the fragment for this particular single fragment is really empty because we can do it all with data binding. So data binding is also super easy to get started with and add it to your project. The only thing you really have to do is add a build feature, data binding true. This is also where you add view binding. There's no view binding in this particular project. But if you also want to add view binding, you would do it in the exact same place and do view binding true. That's it. Just like anything that's in the Gradle, you have to resync your project. But with those 3 lines of code, you can get started immediately. Word of warning, word of probably obvious, but this needs to be in your project and synced before you try to use it. I definitely, having known how to use data binding, I would add it. I would start trying to use it. I have started trying to use it without doing this step and then realize I needed it. And it won't understand what to do with the things that you have already implemented. So this has to be your first step to make it work through the rest of your project. There are 3 types of view binding that we're going to talk about. So I know that you're both Android developers, and so you know a lot about your XML. So we are very used to Android with the attributes we know for all our views equals whatever. So the first type is our one-way data binding. This one is characterized by the quotation marks and the at curly braces around it. So in this case, this is on my button. We'll actually look at the code and look at that a little bit closer, but we recognize Android enabled as a way to control whether your button is clickable or not. And it just takes a Boolean in. And so when you see that at with the curly braces around it, it should signify to you that you're using data binding. So the next type is custom data binding. So again, from 2 Android developers, you should recognize that we changed the namespace of this particular attribute, and also it's not one that you should recognize. So Android Enable is on all your buttons. It's always available. Whereas we know that visible isn't an attribute on our views. We have visibility, and which takes in visible, gone, and invisible. So you can recreate your own attributes, and we'll look at how to do that. But that is the next kind of data binding. It's the custom data binding, where you can define your own attributes and what you need to pass in and what kind of views that they work on. And then finally, we have two-way data binding. And so really similar to one-way data binding, but now you see the @ sign. So that @ sign versus curly braces is going to signify that it's two-way. So when you talk about two-way versus one-way, you're talking about whether the information flows from the view model to the view, or from the view model to the view and from the view back to the view model. We'll look at some cases where that's necessary. So this project is built in MVVM way. And so when I'm talking about my view binding, we're always talking about between the view model and the logic, and then in my view, so in my XML. And most of the fragment is skipped, which is really what we're all about here with data binding. So we'll jump over into the code, but a couple things to point out first to get started with view binding in the actual code is first you need to wrap all your layouts in this layout tag. So you can do that really easily in Android Studio by just right-clicking on your layout, opening the context tools, and then you can make it a data binding layout. So inside this layout, you can obviously see I have my actual layout, which is where I actually build out my UI. So I have that constraint layout, but then I have that wrapped in my layout, and then I have my data tag inside that. So the data tag is where you actually pull your data in. So it gives your XML access to that data. In this case, we'll look at it. I'm pulling in my whole view model because I'm going to use various variables inside that. And so I just pull it in, the type being the main view model that we're going to look at. In my view, so in my fragment, I have my binding that I inflate. So my main fragment binding.inflate. While we don't see the actual file names here, we can look at them in the code in just a second. My layout XML file is named main_fragment. And so when you're creating these bindings, or more so when Android is creating these bindings behind the scenes, they will take the name of your fragment. So mine is main_fragment, and create main fragment with camel case and then binding. And then you can inflate it. And so then you have access to your binding. Then I have to actually set my variables. So in this case, I only have one. We'll come back and talk about the commits after we look at the actual code. So I have my variable defined in my XML VM. And so I have to set that with my binding. So I have binding.vm equals view model. Inside my fragment, in this case, I'm using Coin. We're using the Coin app. So the view model is just injected, and I have access to that and can set it directly. Finally, in this case, we're going to talk about two different ways to set up view binding. In this case, I'm using the @bindable annotations. And so I have a username. It's of type string. I started this app with my username hard-coded into the app because I'm lazy and I don't want to type it out every time I show this. So I have my initial Sierra O'Brien set. And then I also have a setter underneath that sets the value to the field. So the field being the actual username when I change the value. And then I have notified property changed br.username, or br is the binding resource. So that is somewhat how we set this up. We'll go and look at the actual code now. So we saw how all this worked. And so now we can look at, we'll start with the main fragment code. So we see some of the things we talked about. So when you open show context actions, this is where you can just very easily, immediately change your regular layouts into a data binding layout. Alex, who just joined this call, taught me that fun trick, and prior to that, I was typing it all myself. So shout out to her for teaching me very basic tricks in Android Studio. And so then I see that my variable is the VM. So we can go through some of this layout and look at the kind of view bindings we're using, and then also talk about some of those custom view bindings. So when I split my view and zoom in, so we see. So we talked a little bit about those two-way versus one-way data bindings. So a place where we might want to use a two-way data binding versus a one-way data binding is something like an edit text, because that way I can immediately get those updates into my view model. Hang on. So we can immediately get those changes right into our view model. If you've worked with edit text in the past without using data binding, doing that can be really frustrating because you have to add observers to it. So I think a lot about this RX project I did back several years ago when I was trying to learn RX, and having to put a observer on this search field so that my list would automatically edit. So using DataBind, I could have skipped all of those steps because it immediately reflects in my view model. And so I could sit in that view model, take those changes, and update immediately without those extra steps in between. And so for that edit text, I use the two-way data binding so that my username shows up when I launch the app, because I said it, I hard-coded it, and so that data flows from the view model to my UI. But then if I wanted to edit it right now, and change it to a different username, or I also use two-way data binding for the repository, those would immediately flow back so that when I push fetch commits, it would immediately pull the correct data. We also talked about our enabled, and so you see the one-way data binding. So in this case, we have fetch commits enabled. We'll go and look at that function in a minute, but all it does is trigger on true and false as long as your username and your repository name are not blank. So on-click listeners can also be the function on on-click listeners can be defined with data binding. So in this case, I'm actually putting the Lambda function directly into my XML. And so I have these parentheses because on-click listeners take in the view, and then I direct it to a function defined in the view model. So in that case, this is where my list function, my list commits lives. And so this is what launches that coroutine and then makes that network call. And then once that network call is made, we have a variable is loading. Back in the view model, we have loading. It's a Boolean equal to false. And so I use that to change the visibility of my progress bar. So you'll see the progress bar when I'm loading, and then not loading to have my recycler view visibility changed. So those two views depend on the same view binding function. This is the function that we talked about at the very beginning. So I have this @visible. Visible is not a function that comes out of the box with Android because there's actually 3 different states that it can be in. So I have defined a view adapter, which holds my custom view bindings functions. So here I have set visible, and so this is what defines that app visible. First thing to notice that we have this @binding adapter annotation, and that takes in the value visible. So that is what defines the name in my attribute. So looking at that main fragment, I have @visible. In my view adapter, I have my value set to visible. The way that these functions are written is the first thing that it takes in is the type of view that it will work on, and then everything after that is the variables that it needs. So in this case, this function takes in a view, and so everything in Android UI inherits from view. So this will work on any type of view that I can put on it. The really generic, anything goes, I can put it on any type of view and make it work. In this case, I only take in one variable. So I have visible and then visible visible value and then also take in one argument of visible. And so this only requires one single extra attribute on my view. If I wanted to do more, I can just add them into this. So I can add something like here. And then I have to match that number with the function. So then I need an error, and we can also call this a Boolean. So right now, out of the box, required all is equal to false. And so you can also add the require all true. And so then it would yell at me if I went back and tried to run this, because right now on all those functions where I had defined visible or use that visible attribute, I don't have an error attribute defined. So required all will be, will let you switch between needing every single one and throwing an error if your view binding requires more than one variable or not. Obviously, because I'm using Kotlin, I can add defaults to my functions. And so I can set error equals false so that every time it equals that. And then it doesn't make a lot of sense to require all, and I can put false if I always have some defaults defined. So we can take all those off because they're not really necessary and go look at our main view model now that we kind of look through some of those view bindings. So most of them are just like very straightforward types that we know. So we have like our username's just a string, our repo name's just a string, and a various numbers of Booleans. We talked a little bit about that is fetch commits enabled for that button, and it depends on both our repo name and our username both being filled in, because we need both of those to make that GitHub call. And so we can actually make bindable functions based on other bindable variables. And that's how I define this is fetch commits enabled. So in this case, I have a function is fetch commits enabled, and it depends on validating the repo and validating the username. So to make that work and update when either the username or the repo name is updated, I can also add this @bindable and pass in the bindable variable names that I have already used. So we see username matching username and repo name matching repo name. And so behind the scenes, it will pull those together and listen for changes in both of those to update this commit enabled. A word of warning, when you define these functions, they need to match Java getter setter styles. So specifically, this function is fetch commits enabled. When I look at it inside my actual fragment, we see that it's binded as just vm.fetch commits enabled. So it takes that getter setter, getter kind of naming terminology and changes that into a variable. And so if you name it any other way, these kind of functions will not work. I learned that early. So that is a word of warning. So we looked at some really common simple things. In this case, we're also using recycler view. And so if we look at my actual main fragment code, I did really minimal work around this. And the reason is I wrote a more complicated view adapter for recycler views. Recycler views are super common. And so instead of listening for changes from my commits and then setting my data to that recycler view, I can wrap all of that up in some custom view bindings. So we'll take a look. Going back to my main fragment, again, we can see that we have this app items defined. So again, as Android developers, we should be able to recognize pretty quickly that items is not a common or is not defined in the Android namespace. It's not something that exists on that recycler view. So that should immediately alert us that this could be a custom view binding. So in this case, again, on my utils, I now also have a recycler view adapters file defined. And so in this case, we again see that same kind of format. So I have at binding adapters, and now we see that items attribute. And in this case, we see that the view is now defined as a recycler view instead of just a generic view. So this will only work, I can only add this attribute on recycler views. And in this case, it takes in an item, a list of any. So I can use this on any recycler view as long as it has a very specific adapter type. And so that adapter type is also defined. And it's just a really generic recycler view adapter that when let's split these. So when I set my, when my binding adapter items is triggered, then it says if items is not null, then I have an adapter and I call set items. Since I'm using this adapter that I predefined and can use on any list of items, it takes items and sets items and then notifies my data set change. So it's doing the same thing that I would do anyways if I was doing this in my fragment. If I was doing it in my fragment, I would do adapter.set items, and that function will look exactly like this and call notify data change to update my entire list. So back in my main fragment, this is now why we had these extra 2 steps here. Recycler views always need an adapter and a layout manager. Since I know that I'm going to set my items in the future when that data comes back, I can go ahead and set my layout manager and my adapter immediately, and then they're just available and ready for whenever that network call is made. And so I use a linear layout manager because it's just a vertical list of items. And then I have my adapter defined here that sets my items to that UI. And that is most of the data binding in this particular app. So I managed to do this all without using anything super special about data binding besides talking about the @bindable annotation and the @binding adapter. But I did skip over a really important thing that we can come back to now, is that if we look at my main view model, it's actually extending base view model and not just the Android view model class. And so if we look at that, that class implements Observable, and that's what really makes all this data binding work. Once it's there, we can mostly ignore it, but it's a super important part that without it, you won't be able to do it. So we implement this Observable class, and we have these 2 functions that we have to override: add on property change callback and also remove on property change callback. And those 2 things is what that notify property change. So we had those functions in all our setters that said notify property change, binding resource dot username dot repo name. And so that's what makes our every variable that has that binding adapter observable. It's adding observability to all those variables so that when they update, data binding knows to update our UI. Doing it this way also gives you some other functionality. It also means that inside my fragment, I can also listen to changes on those bindable resources. But you should be able to immediately think of a better way to do this. And so we can switch to a different kind of data binding that really cleans it up even further. So instead, we can use LiveData. LiveData is just an observable type of data. Given the name LiveData, it's just data that changes. More importantly, it's data that we can observe. And so if we switch back to our code, I have to switch branches to clean this up. But we'll be able to see that it's really, really similar with just slightly cleaner code. So now I'm back on my main branch. And so now if I look at my main fragment, it actually doesn't change at all. To data binding, these 2 different methods are equivalent. It doesn't matter which one I choose, whether I want to do it with that bindable, there's bindable annotations and bindable resources with that view model, base view model defined, or if I want to use LiveData. So in here, we have no changes at all. It's same with our custom adapters, our recycler view. What has changed is in our main fragment, we now have an extra line inside our onCreate view. So we inflate our binding the exact same way. We set our view model the exact same way, but now we have to bind the lifecycle owner. So observability always has a lifecycle owner. Having written any kind of observer, you always have that first variable to pass in is who is your lifecycle owner for this. Usually you're doing it in fragments and activities, and so it's always just this fragment, this activity. And so now we're passing that over to our, that lifecycle owner over to our UI. So it also has access to that because lifecycle is at the base of observability. So if I jump back into my main view model, first, now we're extending directly from the view model class in Android. So I could completely delete that base view model. I didn't need any extra functionality in it. As you can see, all those 20 lines of codes now is condensed down into just 4. So I have my username defined as mutable live data of a string. Repo name is loading and commits. Obviously, it's mutable live data just because it can change, right? If I want to go and use a different username, one of your usernames, or if I want to change the repo I'm looking at, it needs to be able to update. One change between the two of these is how we're going to define those dependent functions. So now instead of having a function with that bindable annotation to take in different variables, I have fetch commits enabled as a val, so as a value, and I'm using mediator live data. And so mediator live data can take in different sources, and then it will listen to those sources change and update its own value. So really the exact same thing. So in this case, I add my 2 sources, which match exactly to the 2 things that I passed into my bindable annotation. So I have username and repo name, and I'm using the exact same 2 functions that I used before. So I have validate repo and validate username, which does, again, the exact same thing. We're doing the exact same thing here on both branches. And so anytime username changes, it will come into this specific add source, and it will post value to this fetch commits enabled doing validate repo and validate username. Similarly, if my repo name changes, it will come in here and validate username and validate repo name. In this case, they're exactly the same, but you have a lot of availability to change what happens when different things change. So I just need these to validate to make sure both are not empty, regardless of which one is changing. And so that is how both of my sources are defined. Again, everything else is exactly the same. So those are the only real differences. I could take out all those bindable annotations and replace everything with mutable live data. Username and repo name are still two-way data bound. And so now when I change them in the UI, it will post that value directly to that mutable live data. One thing to notice is when you're using mutable live data, whenever you're trying to get that value as a user or as a developer in Android, you always have to do username.value. When you're data binding, you data bind it directly to the mutable live data. So I have vm.username, and behind the scenes, it will get that username.value and update your UI. And so we can just see those exact changes. So we have the lifecycle owner, and then we can extend view model instead of my base view model and all of my mutable live data. So I think that's pretty incredible. If you're on Reddit or the internet, you will quickly find out that people really, really, really have strong opinions on data binding, and they really hate it. And so it can be really discouraging when you're like, should I add data binding to my project? My answer is yes. And my answer is people on the internet hate everything. So you cannot trust them. But having said that, there are some things that you really have to think about when you use data binding. You're generating a lot of code right out of the box to connect all those things, right? That is the magic of data binding, is that they will connect everything behind the scenes and you don't have to. That's amazing and awesome, but it takes time. Someone has to actually, the operating system, the build time, like those things are going to increase because it has to happen for this to work. And as everyone also knows, Android developers hate long build times. So that by itself can put people off a lot. When we talk about custom view binding and optimization, layouts are really expensive in Android. So inflating a layout, updating layouts, redrawing layouts, it's an expensive process. So making sure you're using data binding correctly. I'm really bad at switching between views. So when you're talking about custom view bindings, you want to make sure that you minimize the work that you're doing. If you click into Android code and look at like a set text, you'll see all the different checks that Android operating system will do to make sure that it's not doing work that already has been done. If I try to set my name a second time, Android operating system will be like, nah, I'm not going to reset that. That's really expensive. So we're not going to re-render that for you. We're not going to update it. That optimization does not come for free inside data binding. And so you need to do your own checks to make sure that it's better, it's closer to optimization. I know that I am not writing code that is as optimized as what is being shipped with Android. So if we look at like my personal view adapter, there's ways for me to improve this. For example, I could check to make sure that my view is not visible before I set it to visible. So I can do something like if visible and view dot. I'm so bad. I'm doing a really bad job of. So I can make this check. So I can check if I'm passing in visible. So if I want to set it to visible and my the view I'm setting it on is not already visible, then I can set that to visible. So I don't have to do the work twice. Similarly, when you're thinking about strings, you can check to make sure it's not already there. When you're thinking about image views, check that the image that's already being displayed isn't what you're trying to reset it to, because Android will just try to do it again when you're writing your own view adapters. An easy way to avoid doing this is to just use the adapters that Android itself provides. So when we think about things like text enabled, those things already exist, and there's a lot of way to format your strings and do the things that you're going to do in a custom adapter anyways before you pass them in. For example, if I want to do something like display a time in a very specific way, it makes more sense to me for me to write some kind of function, some util string formatting function to return the kind of string I want, and then use Android text, and then for me to write a new view adapter that will take in the unformatted string, format it, and then post it to that view. So really taking advantage of what Android is already giving you, because you know those are optimized behind the scenes. So only writing things for things that you're going to use a lot and things that you can't do by doing it externally with formatting or updating. So that is that overuse of custom view adapters and also optimization. My third thing is readability and organization and debugging and testing. So you might remember from one of my first slides that this should help with readability and organization. And so I think that that is very true when you know how to read it and use it. If we think about the code that we have here now, I've taken away a lot of code. And so it's much harder to debug. All that code is generated code. It's behind the scenes. You can see it, but it's hard to debug. And so that takes away a lot of the power of the debugging tool. And also it just took away a lot of the readability. I can't literally see anymore where that view is being set. Previously to data binding, if I wanted to update something, I would pass it back to my fragment. And then somewhere in that fragment, I would literally be calling that find view by ID, text box 1, set text equals this. And so if something showed up wrong, I could literally put my a breakpoint on that and see what it was setting, where that was coming from. Now all that has been lifted out of our code, and so it's not as easy to debug. It also introduces a lot of places for logic to live. So now every time that I have some kind of view that I need to update, there's 4 different places I can put that logic. I can put it in my view model and literally do the logic there. I could pass that to my fragment and do a set by ID there, and then a find view by ID and set something there, and then wait for it to update. I can write a custom view adapter to hold that logic every time, or I could literally put my logic inside my UI. So I could put it right into my XML. And so now when you're a junior Android developer and you're looking for a bug, you have 4 different places that you can go and try to find that, which can also be really confusing. My general tips for that is to be really consistent. So for me, I put almost everything in my view model. If it can live in the view model, it's going to be there. You also have to come back, you have to really learn your attributes. So we talked a tiny bit about this, is that we have that Android namespace for most of them. So we have Android text and Android layout with a lot of things are shipped with Android. Whereas you see other things that are apps. So everything that I have in my data binding, my custom data bindings are app. And so that's one way to know that that might be something you have written. Of course, you have things like constraint layout, where this is a constraint layout, and constraint layout is a library that you have to pull in. And so things like layout, constraint in to constraint end are right here, also have that app namespace. You can go around and hack and make your own custom adapters that look like Android, whatever your attribute is. And I really don't recommend doing that because it's really confusing. It's one more layer of complexity for someone who doesn't know your code. So being really consistent about putting in your view model, using the app namespace so that someone can start a guess that it doesn't live inside Android. And then finally, I really try to avoid any kind of layout in my XML, right? Layout or any kind of logic in my XML. I recommend all your layout go in your XML right now. There's no way to debug that logic. It can start really simple. Like, for example, we looked at my, my view adapter and it was just an if-else statement. XML supports the Elvis ternary operator. So I could do visible question mark, visible, else, or colon, not visible. But when do you stop doing that? Like, when do you stop adding logic to your XML? I think that XML, you should try to keep like very pure UI because we have so many other ways to do that logic. If it's something you're going to do consistently and can't be done directly in inside the Android attributes, then it might be a good time to write a custom view adapter to put that logic somewhere consistently with, again, thinking about how to optimize those. So that is what I have wanted to cover for data binding. This is, again, the same presentation as last time, so it's available online. Both branches are available. So one is the main branch, and then the second one is data binding old, because I think of that as an older form of data binding. So I am open for questions about that.
I have a question. So first of all, thank you for showing me this. I haven't used data binding yet. And I looked at it once and I got very confused and I couldn't kind of get it to work. So this was very helpful. I wanted to ask you if you think that there's like an ideal use case where data binding can be used. So for example, if I have an edit text that I need to kind of do a validation after the user stops typing, is it ideal then, instead of if you press a button and then do the validation? Does it have any difference?
Well, I think that it can be a better user experience because the button won't be enabled. So instead of throwing an error, you can just keep it disabled until they've met your criteria. Like long-term, like overall functionality, no, that won't make a difference. If you just check it doesn't work, and then you immediately drop them back on that screen. But this just lets it to like very proactively let your user know that, oh, still not valid, still not valid. In addition, when I think about like my validations, mine are really simple, right? They're just whether or not something's there. But I could, let me jump back over there. Inside these validations, I could make them more complicated and have update other kinds of view bindings. So for example, if you're thinking about a password that needs X, Y, and Z, I could have a validate password and have 3 other mutable live datas for like contains a uppercase letter, contains a number. And so as I validate this, I can update those to display to my user as they're typing, you don't have a number. You need to add a number. You don't have an uppercase letter. That's criteria has not been met. And so I can do it in very real time.
Yeah, makes sense. Thanks.
Anything else? We can wrap this up. So I think next time I am going to do navigation. I think that has been recorded.
Yes, please.
So that's my next one. So it'll probably be in 2 weeks because I can't crank out an Android app every week. But you can DM me if you have any other questions about it. I really like data binding, and I really like thinking about use cases for data binding and custom data bindings versus regular data bindings. So feel free to message me if you have other questions. Thanks.
Thank you.
Yeah. Thank you, Sue.